So what we're doing today is 6.62. 6.62, solving logarithmic and exponential equations. And the first one we're looking at is this one here. So we're told that 2 to the x equals 7. Now, one of the ways we can do this is really grabbing a calculator. And we could start off with, say, 2 to the first power, but we know that that's just going to be 2. Now, 2 squared is going to give us 4, and 2 to the third is going to be 8. Well, that definitely clears what we actually need. You're good. So the next option is just trial and error. 2 to the 2.5. Too small. 2 to the 2.8. Still too small. 2 to the 2. Well, let's get that decimal out of the way. 2 to the 2.9. Okay, now that's too big because it's gone past 7. Doesn't matter if it's 0.01 past 7, it's too big. So that tells us 2 to the 2.8 is about where we need to be at. 2 to the 2.85. Still too big. 2 to the 2.8, 2. Still too big, but we are getting closer. Let's say 80. 2.8. So now we can go 2 to the 2.805. It's actually underneath it because it's smaller than 7. So we can say 2 to the 2.807. 2 to the 2.808. Okay, that's too big. Now we know, so 2.807, then we try 5, and we keep going out to try to get closer and closer to it. However, that's not the most efficient way to do this. Now, the first kind of main step with this is we want to get one term, and I'm using term loosely, on each side. Really, we want, in this case, the base with the variable and the exponent, so 2 to the x on one side, everything else on the other, as best as possible. Now, if we had different bases with variables, we're going to have to do a whole lot more work. We're going to have to try to get it simplified as best as possible. But again, we'd want one term on either side. 2. Because we have that. Our second main step is to get the variable out. I'm going to leave it at that there because in this case, we need to get the variable out of the exponent. When we look at logarithmic equations, we want to get the variable out of the logarithm. We need to get it out of that spot so that we can actually solve for it. So here, the variable is in the exponent. So we need to get it out of the exponent, and to do that, we're going to use logarithms. And because the x only shows up on that left-hand side, we're going to use specifically log base 2. Now, there's a reason for us doing this. Well, log base b of b to the x is x. We went over that in previous lessons. But since then, we have gotten the power property. And our power property says that we can take this exponent and move it to the front, telling me that I have x times log base 2 of 2 is equal to log base 2 of 7. X times log base 2 of 2 is equal to log base 2 of 7. Yes? Now, the specific reason I picked log base 2 of 2, well, let's actually think about how we've talked about this before, because log base 2 of 2 is really saying what? 2, this base to what power gives us the number inside. So 2 to what power is 2? Well, that would be 1. So log base 2 of 2 realistically is 1 telling me that I have 1 times x, which would be x. Telling me that I have log x is equal to log base 2 of 7. Questions on this here? You ready for step number 3? Solve for x, solve for the variable. We want to get the variable by itself. Well, there's a variable by itself for this one here. Yeah. Now at this point here, we can find out what the decimal approximation of log base 2 of 7 is. Now the graphing calculator can do this quite nicely, because we can go math, log base 2 of 7 is 2.807354922, or 2.807. Questions on this here? Questions on anything we've done so far? Now I will say this, especially on the homework, or on the homework and especially on the test. I would like to have both of these. I would like to have the logarithmic form of it, so saying that x is equal to log base 2 of 7, and I do want the decimal approximation. I will say this, if you get the decimal approximation wrong for whatever reason, plugged it in, so on and so forth, you are not losing any points. And especially on this problem here, because what did the problem ask us to do? What's the problem asking? Solve, yes? Getting to this here, is it solved? Yeah, that is the answer, yes? What are we doing to go from here to here? Well, we're solving, but we're doing what? We're plugging it into the calculator, which is a part of solving. But getting that step wrong, is that a solving step or a calculation step? Because this problem is, especially on the test, is asking you to solve it. You solved it. This is calculator error if you don't get the next step. I'm not counting off for calculator. I'm counting on your ability. I'm grading on your ability to solve it. You solved it. Just because that last part's wrong doesn't mean the whole thing should be wrong, or you should lose points for it. It's calculator error. Now, if it specifically asks you to approximate the value of log base 2 of 7, yes, because that's actually asking you to find the approximation. This is just saying what value of x will make this be 7. Well, 2 we ready for the next one? Do we have one term on either side? Yeah. 3 to the x is a term. 8 is a term. So we do have one term on either side. I'm going to rewrite it to give myself a little bit of space. Because our second step is to get the variable out. In this case, out of the exponent. And to get a variable out of the exponent, we're going to use logarithms. Specifically, what log? Log base, what do y'all think? 3. Because when I apply log base 3 to both sides, or log base 3 of 3 to the x, well, the x would move to the front. I have x times log base 3 of 3 is equal to log base 3 of 8. Questions on this here? Questions on anything so far? Well, what is log base 3 of 3? 1. Questions on how we got that x is equal to log base 3 of 8. Now, if we didn't have the graphing calculator, we can still find this, because our change of base, log base b of x, if we wrote it in terms of common logs, would be log of x over log of b. Or if we wanted to use natural logs, it'd be the natural log of x over the natural log of b. So if we rewrote log base 3 of 8, it'd be log of 8 over log of 3. I can grab the 30xs. We'll do natural logs first. Natural log of 8 over the natural log of 3, which is 1.892789261. Yes? Because I think some of y'all plugged it into the graphing calculator with log base. Get the same decimal approximation. Or if we use log of 8 over log of 3, we get the exact same thing. If we round to 3 decimal places, 1.893. Questions on this here? Questions on any of this so far? We good? Did something different? No? Yeah, because again, that's why I do that, especially on the test, because sometimes the calculation, especially with log base, we get one number off, one thing off, and it throws the whole thing off. Seven to the 9x equals 15. Do we have one term on either side? Yeah, even though I have the 9x, it's still a part of the 7. Because really what we're looking for is, do I have 6 times 9 to the 7, or 6 times 7 to the 9x? That's 6. I need to get it moved. I don't want those two terms. Especially if we had plus 3. We need that 3 other side, if we can get it over there. Now, if we had 15 to the x, it's still one term either side. We're going to have to do some steps afterwards, but it still works. What log do we want to apply to both sides? 7. So we apply log base 7 to both sides. Our log base 7 of 7 to the 9x. Throw that 9x to the front. Telling us that we have 9x times log base 7 of 7. Well, that is 1. Telling us that we have 9x times 1. Telling us that we have 9x times log base 7 of 7. Questions on this here? We're done, yes? Is x by itself? No, so what do we need to do? Divide both sides by 9. Well, 9x divided by 9 is nice. because 9x divided by 9 is x. What would log base 7 of 15 divided by 9 be? Well, before that step, it'd be log base 7 of 15 divided by 9. Because log base 7 of 15 is a number, remember? Because when we talk about logarithms, we're saying 7 to what power is 15? So whatever that power is actually the value of log base 7 of 15. I can't just divide the base of 7 or that 15 by 9. I'm dividing its value by 9. Does that make sense? Yeah. Now we can do this in the graphing calculator. Alpha y equals enter, math, log base 7 of 15 over 9 is 0.154629167, or 0.155. Now, if we wanted to do this with the change of base, two ways. We can go log of 15 over log of 7 all over 9, which gives us this here. Questions on these here? We ready for the next one? Now, even though we have 3x plus 7 in the exponent, we still just have a term on that left side. We just have one. 311 is a single term, so that means we can apply this log to both sides. Specifically, log base what? 5. Because on the right-hand side, this is going to end up being log base 5 of 311. Now, even though we do have more than one term up in that exponent, the whole exponent goes to the front, telling us that we have 3x plus 7 times log base 5 of 5. So we do need parentheses, especially around the 3x plus 7, because the 3x and the plus 7 are both being multiplied by that log base 5 of 5. Which here doesn't make a big difference either way, because log base 5 of 5 is what? 1. So I just draw this arrow through it just to say this is 1. And what is 3x plus 7 times 1? It's 3x plus 7. Because 3x times 1 is 3x. Or positive 7 times 1 is plus 7. So you just get 3x plus 7. Is x by itself? No. So we need to solve for x, yes? So we can subtract 7 from both sides. 7 minus 7 here is 0, giving us 3x. Is equal to log base 5 of what? It's still 311. This would not be 304. It is going to be 311 minus 7. Because again, log base 5 of 311 has a specific value. And what that value is, we're taking 7 away from it. And then we're going to divide by 3. So we're saying x is equal to log base 5 of 311 minus 7 divided by 3. So we do have this big old expression, but it does give us the exact value for all this here. And again, either one, if I go to the graphing calculator, alpha y equals enter, math, log base 5, because that's 5, of 311 minus 7 divided by 3 is negative 1.144555,382, or negative 1.145. Questions on this here? Questions on any of this so far? We feel pretty comfortable with these here. Yeah. In that case, we're going to look at these here. Do we have one term on either side? No. We have 4e to the negative 0.3x minus 7. And we would eventually use a natural log, but I'm going to add 7 first because those will cancel. Telling me that I have 4e to the negative 0.3x is equal to 20. Are we good to apply the natural log yet? We have to divide both sides by 4. We could do it here, but it's going to be easier to divide both sides by 4 first, because this would give us e it is equal to 5. I'm just moving it over just a hair. Because it would have worked, but we'd have to rewrite. Because if we'd have left it, we'd have had the natural log of 4e to the negative 0.3x. For me to be able to solve this and simplify, I have to use our product property. And then I'd have to subtract the natural log of 4. Well, natural log of 20 minus the natural log of 4. Whenever I have 2 of the same logarithm subtracted, it's the same as what's inside being divided. So 20 over 4, which is 5, yes? Okay, I'll leave that there. Let's look over here. Do I have one term on either side now? So we want to apply a logarithm, and because the base is e, I mean, technically we could say log base e. We don't normally. We just say what? Natural log. We're implying natural log to both sides. Well, wait. Would it gotten it to the same spot? Yes. Is that a whole lot more steps? Yes. The fact that one division is the equivalent of all of that? Yeah. All right. Power property. So we move that negative 0.3 to the front, so we have negative 0.3x times the natural log of e. Yes? And what is the natural log of e? That's one way I've kind of kept it straight, and I think it's interesting. But yes, it is 1. So negative 0.3x times 1 is just negative 0.3x is equal to the natural log of 5. Last but not least, what do we need to do? Yes, we need to divide both sides by negative 0.3. Telling us x is equal to the natural log of 5 divided by negative 0.3. And nice, honestly, having natural logs is a little bit nicer because it doesn't matter what calculator I have. Because natural log of 5 over negative 0.3, I can just use the natural log button. And it tells me it's negative 5.364793041, or negative 5.365. Questions on this here? Or e to negative 5.365. That was being multiplied by negative 0.3. What's that? 2. Minus 7. Yes. We said this equation is supposed to equal what? 13, yes? And here it equals 13. Not exactly, but was the value of x exactly negative 5.362? It was rounded. Actually, I rounded to the wrong number because that should have been 365. But even with 365, we still don't have exactly 13. Because I ended up rounding up, we went above it. Not by a lot, but we did go above it. So it's not going to give me the exact value because I rounded. For me to get the exact value for this, we're going to have to plug in what? This, the natural log of 5 over negative 0.3 in for x, for it to give us the exact value. And that's also why I wait to the end to round. Because if we round too early, we're going to have rounding errors that are going to compound on each other. We're ready for the next one. What do we do first? Plus 4. And that'll tell me 3 e to the x is equal to 12. Telling me e to the x is equal to 4. And realistically, what is the natural log of e to the x? X is by itself, so we are done. .386. Questions on these here? I think we feel pretty comfortable with these, yes? E is already by itself, so we would take the natural log of both sides. Then we'd have to add 3 divided by 4, or really saying x is equal to natural log of 19 plus 3 over 4, if we solve this. Questions on these here? We're ready for the next one. So, again, the steps still hold true. One, we need to get one term on either side. Now, here we actually do have one term. Now, we will get to some in 663 if we have more than one log and a number outside of the log. We need the logarithms all together, all on the same side, so that we can use the properties of logarithms to condense them into one. Now, we won't come across any where the bases are different, because at that point we're having to start using approximations and doing a lot of other stuff to get to the value. Because here we have one log, we have one term on either side. We can move on to step 2, which in this case is get the variable out of the logarithm. and we're going to use one of our properties. B to the log base b of x is x. It's what's ever inside the log. So here I'm going to apply a base of 2. Because this 2 to the log base 2 of 5x minus 17, well, that 2 and log base 2 are going to simplify out, giving us 5x minus 17. And that's equal to 2 to the third. Questions on this so far? Now my question for you is this. Is 2 to the third a nice number? What is 2 to the third power? Almost. 2 to the third is 8. Now the reason I say that that is a nice number is that, one, it's not irrational. We don't have a non-repeating, non-terminating decimal. So if we were using, if it said the natural log of 5x minus 17, we'd have to apply a base e. E to the third power is not a nice number. It's an irrational number. Just like with our previous ones with the logarithms, we're going to wait till the very end to find out what its value is. But here, 2 to the third is a nice number. It's 8. Would 5 to the 40th be a nice number? Let's see what it is. 5 to the 40th power is, it's way too big. Now, it is an integer, but it's too big for us to actually work with. We just leave it in exponential form. Now we move on to step 3, solve for x. So the first thing we would do is now for most of the problems that we'll do with this one here and in this assignment, we don't necessarily have to check our solutions, but any value of x that we get, for it to work, cannot make 5x minus 17 be negative or 0. The whole expression be negative or 0. So if I wanted to check it and make sure, well, we can go log base 2 on 5 times 5 minus 17. Well, 5 times 5 is 25. And 25 minus 17 is 8. 2 to what power is 8? And that is what we wanted it to equal, yes? We could have also plugged log base 2 of 5 times 5 minus 17 into the graphing calculator, hit enter, and it would have told us it was 3. Now, if for some reason we solved it, plugged it back in, and told us log base 2 of negative 8 is what we got, this doesn't work. We can't have a negative inside that log. Does not work, cannot happen. So that's the big issue. We cannot have 0 or negative inside the log. Do we have one log on both, or one term on both sides? Yeah. So we can go about getting this log, or getting the variable out of the logarithm by putting both sides to the base of 3. Because here, 3 to the log base 3 would simplify. Add 9. Telling us 10x is equal to 90. That's it. log base 3 of 10 times 9 minus 9 is 4. Is that what we said it's supposed to be? Yep. So that's it. Questions on this here? We put both sides to the base of 2, telling us that x minus 6 is equal to 2 to the 5th, which is 32. We could make it harder and have quadratics inside there, but that's not really making these problems harder. It's just making our steps to solving longer. But that's it.